Hey y'all, we're gonna look at ellipses today. So an ellipse is like a stretched out circle in one direction, I guess. So here's the little information about ellipses. So the standard form is, if you notice, is just like a circle, except for instead of the equaling to the radius squared gets divided into different stretch factors, so an A and a B. So a horizontal ellipse is going to have a longer horizontal axis. So the length of the horizontal axis from the center to the vertice is the length A. So if you add those together, A plus A, that would give me 2A, would be the length of the major axis. And then the B value is the length from the center out to the co-vertices. Okay, and again, B would be horizontal in a vertical ellipse, so co-vertices, and A extends out to the vertices. This should be a review from your Desmos, okay? So write these things down, and we're gonna, the other thing that we have is the distance from the center to the focus point, or the foci, plural. On a horizontal ellipse, the foci are always on the major axis, so the A axis. So the C value is the distance. The distance from the center is equal to C. So we're going to have like, I'm going to go ahead and erase these. Oops. Okay, so the focus point is the distance from the center to the focus. It's the C value, and we have it on both sides of the center. Okay, so the equation is the same for a vertical and a horizontal ellipse. And then the last major thing is our eccentricity. Basically, this tells us how elliptical our ellipse is. I know that sounds weird. So if you have, if your E value is between 0 and 1, you have an ellipse. And if the E value is closer to 0, it means that the foci are closer together, or closer to the center point, which means that you're going to have more of a circular shape. This is more circle-like. Not quite a circle, but more circle-like. Okay? And then if we have it close to 1, the distance, if the ratio of C over A is close to 1, so pretty far away from the center, the shape is more elliptical. That looks like a potato. All right, so a couple examples. First off, we're going to write the equation of the ellipse. So what are the important pieces that we have to have in order to write the equation of an ellipse? We need our h comma k, which is our center, and our a value and our b value. Our center, I'm going to go ahead and draw in my major axis, and that's a distance of 1, 2, 3, 4, 5, 6, 7, 10 units. So half of 10 units would be 5 units. So my center would be right here. And then I also can see that my A value is equal to 5, because A is always the longer axis. And then my B value, half of 4, is going to give me 2. And that leaves me with a center of 2 comma negative 1. So the equation of my ellipse would be x minus 2 squared over 5 squared plus y minus 2. Y plus 1 squared over 2 squared is equal to 1. It's always equal to 1. Okay, that's the equation of my ellipse. Okay, just for funsies, if I were to find the distance of my focus point, I would do c squared is equal, so this is for the foci distance, c squared is equal to a squared minus b squared. So c squared is equal to 5 squared minus 2 squared, so 25 minus 4, which gives us 21. So c is equal to the square root of 21. So, which is about equal to 4.58. So I'm going to go on the major axis, 1, 2, 3, 4.58, and negative 4.58 from the center. If I were to write these as points, let's say points, I would have 2 plus negative 1 is my common negative 1 is my center, and I'm adding and subtracting to the y, so I'm going to be plus or minus square root 21. Those are my foci points, I think. Okay. And then our eccentricity. So this tells us a little bit about our shape. Okay. So E is equal to the ratio of C over A. I know C is equal to root 21 and A is equal to 5. This gives me a value of 0.92. Is that close to 0 or is it close to 1? We are close to 1. So the ellipse is very ellipse-like. Is stretched, we'll say. Okay. All right, so we're going to sketch the conic and then state the center, foci, and eccentricity. And then we'll take a break from there. Okay, so the center is my H and my K. So that's 2, 3. My A is equal to, actually A squared is equal to, just kidding, what did I do wrong? A squared is always the bigger value. Okay, the bigger stretch value. So A is equal to 5, and then B squared is equal to 16. So B is equal to 4. So I have some important pieces right here. Those are kind of weird colors together. Okay, let's get a sketch. Center. 1, 2, 1, 2, 3. Okay, are we a vertical or a horizontal ellipse? Well, since the bigger value is under the y, we are a vertical ellipse because the y is more stretched. 1, 2, 3, 4, 5. 5 up from the center, 5 down, 1, 2, 3, 4, 5. 4 to the right, 1, 2, 4, and 4 to the left. Okay. Let's get our eccentricity is equal to C over A. So our C value, we better find our C value actually. So for the foci distance is C squared is equal to A squared minus B squared. So C squared is equal to 25 minus 16, which is 9. So C squared is equal to 9. So C is equal to 3. So I get 3 over 5, which is 0.6. So this is kind of somewhere in the middle. It's stretched a little, but not quite a circle. Okay. The last thing I can do is graph in my foci. So 1, 2, 3, and 1, 2, 3. And the point, the focal points would be, did I change in the x or the y direction? So the center is 2, and the y is 3, and then I change in the y direction, so I'm plus or minusing 3. So I have 2, 6, and 2, 0 as my focal points. Okay, so that's it. Okay. Ooh, one more thing, our vertices. So the vertices are on the major axis, and they are the edges of our ellipse. So one vertex would be here, and one vertex would be here, because they're vertical, because it's a vertical ellipse. So I'm going to go to my center point, which is 2, 3, and then I'm going to add on my a value to my y. So 2, 3 plus or minus my a value, which is 5. So that gives me 2, 8 and 2, -2. Honestly, you can count these on the graph, but this is the algebra that supports it. All right, we're going to take a break there, and I will make another video for you.